So speaking of being grateful, some of the things we do here at Exponential Medicine are sometimes improvised, and we had a little change in our schedule about a week ago, and I thought something's going to manifest, and indeed it did. So I'm really lucky that we're happy to have a new kind of session this morning, focused on the microbiome, something we've touched upon, something that's certainly moving into the exponential realm, but it's going to have really interesting implications for health and medicine. And I brought our divine manifester, Stein, together with Paul Robin, who is the Associate Vice Chancellor of UCSD, who are going to lead us in a session exploring the cutting edge of the microbiome and where it's going to take us. Lee and Paul.
Hello, everyone. We're going to start off by looking at this bug. This is a tick, and the tick seriously changed my life. Actually, the gut of the tick has forever altered my son's life in a way that is quite meaningful. My son, Skylar, this is a picture with him with his section at Harvard Business School. The difference between him and everyone else in this picture is that they'll be graduating this May, and he has spent the time since this picture on a neurological journey, a neurological challenge is the best way to say it, because of that particular tick. And actually, it was a bacteria, Borrelia burgdorferi, which is in the gut of that tick, is where it gestates. And that is the beginning of Lyme disease. Lyme manifests itself in many different ways. There's a neuro-Lyme. Well, they don't really call it neuro-Lyme. It basically will cross the blood-brain barrier. This is a very sinister bacteria because it will take many, many different forms. And if it thinks it's being attacked, it will even hide itself by encapsulating itself. You can think of roly-poly, where it'll just lay in wait, and when the immune system is compromised, it will then come out again. Now, to show you the significance of Lyme disease, here's a Center for Disease Control map, and this is from 2001 to 2012. The CDC reports somewhere in the neighborhood of 30,000 cases a year. It's estimated to be underreported by a factor of 10. If you haven't encountered this disease or somebody in your family, you will shortly. Basically, the main treatment for it is antibiotics. In Skylar's case, there were cocktails of antibiotics put together, which was very unusual because Skylar didn't have antibiotics when he was a kid growing up. My wife, Juniper, her attitude was avoid antibiotics at all costs. And now Skylar ended up with a cocktail of antibiotics. And what we found is that the cure for the Lyme, because he seems to be doing extremely well with the Lyme, but the cure for the Lyme had a tremendous cost. And that cost we're finding in the microbiome. Now, there was a book published by Martin Blasser that we encourage everyone to read. It's really essential reading called Missing Microbes. But if you look at the graph on the left, you're going to see that infectious diseases have decreased virtually exponentially, like all things singularity, but the immune disorders seem to be increasing exponentially. There's correlation here. There's not all of the science to prove that those two things are related, but let's not underestimate that as I move forward, going through a little bit more of a description. Because of Dr. Daniel Kraft, because of Exponential Medicine, Singularity University, the X Prize Foundation, the TED Med, and the community that we are all involved in together, I had the luxury of knowing about microbiome and seeing glimpses of it over the past few years. And so when Skylar was diagnosed, the Craig Venter Institute, JCVI, started an IRB-approved study on Skylar that was funded by the George and Betty Harbaugh Charitable Foundation, where we started to sequence Skylar's microbiota, his stool, his saliva, and his urine every single week. Okay, so we are now deep into a microbiome study, and as I said, from that original tick, our world is very, very different as far as how we live in the world and understand microbes. Now, this graph is basically what we found with Skylars biome. And these are on the bottom, across the bottom, are the JCVI analysis of the bacteria in his gut. And the thing that's really interesting about this is that they should be a rainbow of colors of different guts. I'm not here as a scientist offering scientific information. I'm just a dad who has a child that, by all standards, looks really healthy clinically as it relates to the original diagnosis of Lyme disease. But because of the sequencing that's being done, without that being a rainbow, his gut indicates that he is susceptible from some very serious immune disorders. And what we're working on now is how to reconstitute one's microbiome, because the gut is quite meaningful. Now, what we also found recently, and I'll just hit this quickly, there's all kinds of reports that you can Google and find about the number of bacterial cells in our body far exceeds the number of human cells in our body. What people started doing many, many years ago, somewhat experimentally in Minnesota and in Australia decades ago, was a theory that if people had problems with their bowel, that maybe you could do what they are calling fecal matter transplants, where they would take and it's fecal microbial. It comes with lots of different types of names as far as what they're calling it. But basically, it is they started taking stool from healthy people, processing it, and inserting it into the guts of unhealthy people. And there started to be some really amazing reactions as far as people getting better. In particular with a bacterial overgrowth called C. diff that happens. Now, what happened here is that some key research was done where we couldn't do this, and as Paul will talk about in a few minutes, we couldn't do this a number of years ago because the cost of sequencing was just too high. But what they did is they took the fecal matter of fat mice and they transplanted it into lean mice. And the lean mice got fat with no change of diet or exercise. And they took the lean mouse fecal matter and transplanted it, and the fat mice got skinny. So there was a correlation now between the colony of bugs in your gut and your health condition, at least as it related to obesity. I think there should be one more picture here. They are also finding connections between the gut and neural connections. They're finding connections between correlations at this point in time, correlations between the gut and serotonin levels. They're finding correlations between immunotherapy and the gut as far as it's going. And we encourage people to read David Perlmutter's book on Brainmaker as a additional, all of his books, but that would be very useful. So basically, that's the background as far as our quick deep dive as a family into the study of microbiome. But we had the real benefit of being here in San Diego with the most remarkable work that's taking place in microbiome, in our opinion, the most remarkable work that's taking place anywhere in the world. And we're very, very active in this area of microbiome, and I'll come back and talk at the end again, but I'd like to turn it over to the Vice Chancellor for Innovation at the University of California. Paul?
Thank you, Lee. Good morning, everybody. So, first of all, it's kind of scary to think that we're all 90% bug and only 10% human, right? I'm here to tell you about UC San Diego's support for this microbiome effort. Why are we interested in this and why are we supporting this? Because this exploration in microbiome, we believe, is the new frontier in medicine. We believe that this has the potential to completely change the way that we manage health and disease in the future. And we also believe that we are the ones that are uniquely positioned here to be the global leaders in this field. So As Lee pointed out, the microbiome is extremely important. From the moment of your birth, all throughout your life, you're interacting with the environment to shape the balance of microbes that live in you and on you, and it's that balance of microbes that keeps you healthy. And there's growing evidence now to suggest that if that balance is in any way perturbed by stress or environmental factors or antibiotics, as Lee pointed out, that you can go from being in a state of health to a state of disease. And we're not just talking one disease. The microbiome has been linked to a vast array of diseases, everything from autism, depression, cancer, diabetes, obesity, gastrointestinal disorders. The list goes on and on and on. And the reason why the microbiome is so important in this, and not to go deep into the science in it, but the bugs in your gut, essentially, and the metabolites that they produce have an effect on the central regulatory process in your body, everything from digestion through the nervous system, immune system, endocrine system, etc. And it's through those processes that they have the effect, these vast, wide-ranging effects in your body. And an example of that is babies that are born through C-section do not have the advantage of coming in contact with the mother's microbiome, which is present in the birth canal. So those babies are at a distinct disadvantage from birth, and as you can see, they're at a significantly increased risk of all sorts of different diseases. So this just shows you the importance of developing the microbiome right from birth. So understanding this microbiome in detail and how it really relates to health and disease, we believe is going to help us develop new interventions, therapies, and diagnostics, which will change the face of management of both health and disease. And in order to take advantage of this, our chancellor just 2 weeks ago announced the formation of this microbiome initiative. This is a multidisciplinary initiative across the campus, which really is aimed at putting us in the forefront of this field. The first thing that we did is we hired the best people. Rob Knight is internationally recognized as the leading voice in microbiome research. He's the co-founder of the American Gut Foundation, our project. He's central to the NIH Human Microbiome Project and so on. And he basically was the guy that developed the techniques to allow us to sequence very complex mixtures of these microbes and to be able to distinguish individual species in there. And that really is central to be able to understand how microbiome relates to health and disease. And as Lee also pointed out, we're at a perfect time to do this because the cost of sequencing has exponentially decreased over the last number of years. So if you combine what he's developed with the ability to do massive amounts of sequencing, this is the perfect time to be able to do these types of studies. Now, UCSD is uniquely positioned with the technologies and the tools that we have available to us to be able to become the leaders in this. Not only do we have the sequencing, we have notobiotic capabilities, which I won't go into. We have the clinical capabilities. And most importantly, I think, we have the supercomputer capabilities. So with the activation of our Comet supercomputer just a couple of months ago, we now are one of the few sites in the country that have the ability to be able to analyze the vast amounts of data that this is going to yield, to be able to really dig into how this microbiome is working. So we have the people, we have the capabilities. We also have, I think, the vision to understand that this is a multidisciplinary approach. So we have the biology department involved in this to understand the system. We have the clinical guys and the health sciences and the social science people to understand how does this really impact real people. We have the engineers not only to give us the analytics and the supercomputer capabilities, but also to develop virtual world displays of very sophisticated data sets so that we can really look at these in a meaningful way. And we also have the nation's top Oceanography Institute and Environmental Studies Institute and Scripps Oceanography, because it's crucially important that we understand how we as individuals are interacting with our environments to shape the microbiome. And to give you an example of that, the ocean right out there, that's kicking up millions of microbes continuously in these aerosols. And all of us sitting here in this room are being impacted by those microbes. And that's shaping our microbiome as we speak, right? So we have to be able to understand how we as individuals are interacting with the environment, how that's shaping our microbiome, and what that has to do in terms of keeping us healthy and keeping us from getting diseases. So not just that, though. I mean, this isn't all just about doing clever science, right? We also, in this initiative, have the business school, we have the innovation departments, where we manage everything from the intellectual property through accelerated business creation, investment in businesses, very, very close ties to the private sector, these companies who are actually going to develop the products and services that are going to make an impact. So this isn't just about doing science. This is about having a real impact and changing the face of healthcare as we know it. So with that, I think what I'll do is I'll let the Chancellor of UCSD just for a minute tell you what his vision for this initiative is.
Hello, I'm Pradeep Khosla, Chancellor of UC San Diego. Not long ago, we developed UC San Diego's first ever strategic plan that sharpened our vision as a student-centered, research-focused, service-oriented public university. Today, I'm proud to announce a new interdisciplinary effort that will advance our work in this area, the UC San Diego Microbiome Initiative. With this bold new research project, we will further our understanding of the communities of bacteria, viruses, and other microorganisms that live on our bodies and everywhere around us. And we will find new ways to manipulate the microbiomes for the benefit of human and environmental health. We at UC San Diego are uniquely positioned to meet this challenge. The UC San Diego Microbiome Initiative will draw from our expertise in our School of Medicine, Jacobs School of Engineering, Division of Biological Sciences, SCAC School of Pharmacy and Pharmaceutical Sciences, Scripps Oceanography, the Rady School of Management, and the UC San Diego Health System, and many, many other disciplines. Two outstanding faculty members will lead this initiative. Dr. Rob Knight, who's a pioneer in the microbiome field, and Dr. Kit Pogliano, a microbiologist and a leader in our Division of Biological Sciences. They will unite and leverage UC San Diego's expertise and resources across a campus-wide effort to advance our microbiome research and create educational opportunities for our students. We are excited about this new initiative, and we know it will transform lives.
So, just to reiterate, this exploration of microbiome is the new frontier in medicine. We are beginning a journey of exploration here, which we believe has the potential to fundamentally change how we manage health and disease. And we're inviting you to take that journey with us.
Thanks, Paul. So basically, you saw a bit of the science, you saw a bit of a personal story. We know that we are going to find the gift in Skylar's medical condition. We always look for the gift in difficult situations, and in this case, the gift has opened us up into this world of microbiome. We're all sharing biomes right now. There's some preliminary research, and everything in this field is preliminary. Preliminary research that shows that there's a cloud of microbes around us that we are exchanging. In some respects, there's an analogy that we could take to orthopedic medicine, which is that this is as revolutionary a change in our awareness of medicine as orthopedics were the day before and the day after the X-ray. Okay, this is a fundamental change. Now, as this research comes out, if we start finding these correlations with scientific validity as to serotonin levels that tie into microbiome populations. Think of your microbiome in, they consider there to be 5 biomes. Your stool, your saliva, your urine, your skin, and the vagina. There's some theories that say no, that organs have their own biomes as well. So that these constitutions, think of them as pie charts. With the slide that Paul showed, that the cost of sequencing coming down, the corollary axis on there was the amount of research that's taking place. 10 years ago, it was scant research. 5 years ago, it just started. We've gone from a couple hundred articles to thousands of articles in this new field of science. And we're basically at the forefront of a re-understanding of medicine as we know it. I think we're leaving the antibiotic age of doing antibiotics for everything for acute, but we are moving into a microbial, call it bacteriotherapy analysis. When we start finding for the documented correlations based on the work that Larry Smarr is doing with the Comet supercomputer tied to Rob Knight's work, we're really in a situation here to find these correlations to all the things we've talked about, plus a number of different disease states. And if you think that managing your biome may be the reason that affects your health, and that there is a completely new axis of wellness that we've not talked about. So there's a number of ways to play. Direct donation to UCSD is, of course, really welcome. PRIs for foundations so that there's direct investment if they don't want to make direct donations. I'll talk about that in 1 minute. Or equity investment opportunities through the offices of technology transfer or working with us directly, because as I said with that original tick, this is the new focus of our lives, of working in this new area of science. To me, who was there, it feels very similar to the Internet 1993. We don't know where this is going, but we know that this is rather remarkable in its scale and in its implications. We talked a little bit about, we talked about the NIH work with Rob Knight and funding from the government there. We talked about the National Science Foundation research funding that's coming into a century of CPU with Larry that's coming up. We've talked about the Center for Disease Control. So the government is very, very active in this early stage of where we're going, but also the Internal Revenue Service is giving foundations tools, not just for this, but I wanted to point it out for those who weren't aware, that we're looking to do things related to program-related investments, which is Section 4944C of the Internal Revenue Code. And if those foundations meet these tests, then there are ways for foundations to participate, and we're setting up those mechanisms now to keep them focused and directed on this microbiome work as well. But as a member of the San Diego community for many, many years living here, we are so proud and so honored and so humbled to see the work that the University of California, San Diego is doing, to know that the center of this new research is coming out of the University of California, San Diego, is just so exciting. And the fact that we're all here together today having this conversation. Paul, I'd just like to honor you and honor the Chancellor and honor this tremendous group of scientists. And when the announcement was made by the university, I think there's some statistic that came up that Paul might want to refer to, which is over 100 scientists signed up within 24 hours that they wanted to be working on this project with the university. So we welcome you to the frontier of the science of microbiome, and we look forward to participating in this most amazing journey of understanding our bodies and understanding life as we know it. So thank you very much, and thank you, Daniel, for having us. Thank you.
Thank you. Thanks. And actually, during the lunchtime breakouts today, we'll be doing a breakout session related to the microbiome. Hope you can join that conversation.
Thank you very much.
Okay. Thanks.